Elon Musk has revealed a humanoid robot to eliminate boring jobs. Tesla is launching a humanoid robot that Elon Musk believes can help eliminate dangerous, repetitive and boring tasks, while promising its human handlers will be able to outrun it. The electric car maker's eccentric chief executive claimed the Tesla bot would enter its prototype phase.
Now, unlike Dojo, obviously that was not real. So Dojo is real. The Tesla bot will be real. But basically, if you think about what we're doing right now with the cars, Tesla is arguably the world's biggest robotics company because our cars are like semi-sentient robots on wheels. And with the full self-driving computer, essentially the inference engine on the car, which will keep evolving obviously, and Dojo, and all of the neural nets recognizing the world, understanding how to navigate through the world, it kind of makes sense to put that onto a humanoid form. And we're also quite good at sensors and batteries and actuators.
Although Mr. Musk's companies have notoriously pushed back their timelines on other ambitious projects such as fully autonomous cars. Speaking at the electric car maker's AI Day event, Mr. Musk promised the Tesla bot will be real, with a human shape, weigh around 56 kilograms, stand 5 feet 8 tall and be capable of lifting 68 kilograms. He also revealed developments in Tesla's self-driving car capabilities and powerful computer chips. The Tesla founder and world's second richest person, worth $178 billion, said people would easily be able to run away from the robot that would have a top speed of just 5 mph. While promising the robot will be friendly, Mr. Musk added, "We're setting it such that it is at a mechanical level, that you can run away from it, and most likely overpower it. Hopefully that doesn't ever happen, but you never know. 5 miles per hour, if you can run faster than that you will be fine." The 50-year-old Tesla boss has been particularly wary about the dangers of artificial intelligence, claiming a super powerful AI could be more dangerous than nuclear weapons. He added that robots will start to end labor shortages and change the future of work. "This is why I think long-term there will need to be universal basic income," he said. "But not right now because this robot doesn't work. The future of physical work will be a choice. If you want to do it you can do it, but you do not need to do it." Mr. Musk said Tesla was arguably the world's biggest robotics company due to its development of cars capable of semi-autonomous driving. Of the Tesla bot, he added, "We think we'll probably have a prototype next year." The Tesla boss has previously made bold promises about the company's AI capabilities. His Tesla bot launch was not accompanied by any demonstration. Its autopilot system for Tesla cars, ultimately intended to be a fully autonomous driving system, was first teased in 2013. Its cars have come with advanced lane and parking assist features using cameras and software since 2014. 2 years later, Tesla started selling cars that it promised would include the capability for full self-driving after software updates, and regulations allowed the system to be launched widely. However, the feature has yet to be launched for widespread use. Tesla used its event to demonstrate some of the advances it was making in computer vision and machine learning. It also revealed a semiconductor chip it was using to develop its planned Tesla supercomputer, Dojo. The event came days after U.S. regulators launched an investigation into Tesla's autopilot system amid fears that it was being confused by flashing emergency lights. The U.S. National Highway Traffic Safety Administration said it would investigate a dozen crashes involving the autopilot system.
How we started Project Dojo. Our goal is to achieve best AI training performance and support all these larger, more complex models that Andre's team is dreaming of, and be power efficient and cost effective at the same time. So we thought about how to build this, and we came up with a distributed compute architecture. After all the training computers out there are distributed computers in one form or the other. They have compute elements in the box out here connected with some kind of network. In this case, it's a two-dimensional network, but it could be any different network. CPU, GPU, accelerators, all of them have compute, little memory, and network. But one thing which is common trend amongst this is it's easy to scale the compute It's very difficult to scale up bandwidth and extremely difficult to reduce latencies. And you'll see how our design point catered to that, how our philosophy addressed these aspects of traditional limits. For Dojo, we envisioned a large compute plane filled with very robust compute elements backed with large pool of memory and interconnected with very high bandwidth and low latency fabric and in a 2D mesh format. And onto this, for extreme scale, big neural networks will be partitioned and mapped to extract different parallelism, model, graph, data parallelism. And then a neural compiler of ours will exploit spatial and temporal locality such that it can reduce communication footprint to local zones and reduce global communication. And if we do that, our bandwidth utilization can keep scaling with the plane of compute that we desire out here. We wanted to attack this all the way, top to bottom of the stack, and remove any bottlenecks at any of these levels. And let's start this journey in an inside-out fashion, starting with the chip. As I described, chips have compute elements. Our smallest entity of scale is called a training node. And the choice of this node is very important to ensure seamless scaling. If you go too small, it will run fast, but the overheads of synchronization and software will dominate. If you pick it too big, it will have complexities in implementation in the real hardware and ultimately run into memory bottleneck issues. Because we wanted to address latency and bandwidth as our primary optimization point. Let's see how we went about doing this. What we did was we picked the farthest distance a signal could traverse in a very high clock cycle, in this case, 2 gigahertz plus. And we drew a box around it. This is the smallest latency that a signal can traverse, 1 cycle at a very high frequency. And then we filled up the box with wires to the brink. This is the highest bandwidth you can feed the box with. And then we added machine learning compute underneath, and then a large pool of SRAM. And last but not the least, a programmable core to control. And this gave us our high-performance training node. What this is a 64-bit superscalar CPU optimized around matrix multiply units and vector SIMD. It supports floating point 32, bfloat 16, and a new format, CFP8, configurable FP8. And it is backed by...
In the UK, the government plans to make hands-free driving on British motorways legal by the end of the year, although it will initially limit this to speeds no higher than 37 miles per hour. So guys, what are your thoughts on this concept? Let me know down in the comments section.